हाय एवरीवन, स्वागत है आप सबका हमारे इस यूट्यूब चैनल में। माय नेम इज अभिषेक एंड वंस अगेन इन फ्रंट ऑफ यू विद येट अनदर 20 क्वेश्चन फॉर द अपकमिंग एनडीए एज वेल एज सीडीएस एग्जाम। तो आज भी हम बात करेंगे रिगार्डिंग इलेक्ट्रोमैग्नेटिज्म, इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड। कल मोस्टली क्या एंटायरली जो क्वेश्चन थे दैट वाज ऑफ इलेक्ट्रिक फील्ड। आज जो क्वेश्चन हम डिस्कस करेंगे दैट इज विद रिस्पेक्ट टू magnetic field. So let's start without any delay. And here is question number 1. Magnetic field. But before that, let me tell you, जिन्हें नहीं पता है, those who are new, there have been a frequency of 25 question. 25 question पूछे जाते हैं in of physics in NDA, and one question is of 4 marks. ठीक है जी, 25 क्वेश्चन पूछे जाते हैं, एक क्वेश्चन होता है 4 नंबर का, तो दैट इज ऑफ 100 मार्क्स। 100 मार्क्स की फिजिक्स पूछी जाती है इन द जीएटी सेक्शन, जनरल एप्टीट्यूड टेस्ट। ठीक है, एंड देयर इज नेगेटिव मार्किंग ऑफ कोर्स एज पर यूपीएससी, एंड दिस इज 1/3 नेगेटिव मार्किंग ऑफ 1/3। ठीक है, in CDS the frequency is of 10 question approximately. ठीक है, so basically in CDS it is more about the general science, in NDA it's more about the physics. तो अब जो 20 क्वेश्चन हम करेंगे आज, उसमें दोनों कवर करने की कोशिश करेंगे। ठीक है जी, तो चलिए लेट्स स्टार्ट। Magnetic field is basically started from when charge starts moving. जब चार्ज मूव करना शुरू करता है ना, तब जा करके मैग्नेटिक फील्ड आता है। अगर चार्ज रेस्ट पे है तो सिर्फ इलेक्ट्रिक फील्ड आएगा, लेकिन अगर चार्ज मूव भी कर रहा है तब मैग्नेटिक फील्ड आएगा। एंड दिस इफेक्ट वाज फर्स्ट नोटिस्ड बाय ओरेस्टेड। ठीक है, पहला क्वेश्चन यही है that magnetic field is produced by the flow of current in a straight wire. The phenomena was discovered by, who was the first person who discovered this? That when a current is passing through a wire, the wire exhibit the property of magnetism. So it was first identified by Oersted. Yes, first identified by Oersted. सबसे पहले जो आइडेंटिफाई किया था वो किया था Oersted ने, and let me tell you the full name is Hans Christian Oersted. The full name was Hans Christian Oersted. Full name है Hans Christian Oersted. He was the first one who discovered that. ठीक है, और कैसे डिस्कवर्ड किया था? He took one resistor connected with a battery along with a key, and he placed a magnetic needle with that circuit. As soon as current start passing, as soon as the key is closed, जैसे ही की क्लोज्ड हुई, देयर इज अ डिफ्लेक्शन इन दैट। मैग्नेटिक नीडल के अंदर डिफ्लेक्शन शुरू हो गया। सो वहां से ही गॉट कंफर्म्ड अबाउट दैट व्हेनेवर देयर इज अ करंट व्हिच पास थ्रू अ सर्किट, देयर इज अ मैग्नेटिक फील्ड दैट हैज बीन एग्जिबिट बाय द स्पेसिफिक वायर। ठीक है, आई होप द क्वेश्चन इज क्लियर टू ऑल ऑफ यू। क्वेश्चन नंबर 2, which one of the following statement is not true about magnetic field lines? You are given with the sorry, you are given with the 4 options, and what you have to do is to find out that which one is not correct. So let's read all the 4 options one by one. The first one is the magnetic field lines are closed and continuous curve. Yes, that is true. They originated from north pole and terminate at the south pole outside the magnet. Inside magnet, it is exactly opposite to that. They started from north pole and terminate at the south pole. Second is no two field lines can cross each other. That is also correct, because if they do so, if two field lines cross each other, if two field lines cross each other, then there will be two direction of magnetic field at a single point. magnetic field की दो डायरेक्शन हो जाएंगी and that is not possible. That is not possible. So that's why. Third one is crowdness of field line represent the strength of magnetic field. Again, it's correct. Greater the number of field lines, stronger will be the magnetic field. Let's move to the last one. That is the direction of field line is from north to south pole inside the bar magnet. This is in contradiction to what I have told you earlier. Outside the bar magnet, it's north pole to south pole, but inside the bar magnet, it's south pole to north pole. It means that the fourth one is wrong. जो ऑप्शन नंबर 4 है वो गलत है. इसका सीधा सीधा मतलब ये है कि जो ऑप्शन नंबर 4 है वो गलत है. चलिए, नेक्स्ट थिंग इज third question. A circular coil of radius 10 centimeter having 100 turn carrying a current of 3.2 ampere. The magnetic field at the center of the coil. This is a numerical. If I want to find out magnetic field, it is simply mu naught Ni upon 2r for circular wire at the center. So if I put the values like value of mu naught 4 pi into 10 raised to the power minus 7, number of turns, it is given to us that there are 100 turns, current is 3.2 ampere. What about radius? It's in centimeter. So first of all we have to change it into meter. In order to have the symmetry of the measuring system, the units, you have to take all the units in a single measuring system. Either it could be SI, it could be CGS, it could be MKS. That totally depends on the question. So let's try to solve it. This is cancel. B is equals to 4 pi 10 raised to the power minus 7. This is 3.2. This 10 will go in the numerator, 10 raised to the power 3 by 2. This is 2. This is 2. Now see, 10 raised to the power minus 3, minus 3, minus 4, minus 4. Let's try to solve it. 2 into 3.14 into 3.2 into 10 raised to the power minus 4. So first of all, you have to solve it. है ना? 32, 2 4s are 8, 2 1s are 2, 2 3 6, 4 3s are 12, 4 9. So this will be 2 into 8 4 10 10 1 0 0 4 8, and there is decimal after 2. 100 into 48 10 to the power minus 4, 200.48 into 10 raised to the power minus 4. If like I have to cancel it a little bit, एक जीरो उधर ले जाइए, 2.04 into 10 raised to the power minus 3. So this comes out to be the first option. 2.01 into 10 raised to the power 3. Sometimes you might get a numerical, and that you can see on the screen. ठीक है जी, but not so difficult. All you have to do is to remember the formula. आपने कौन सा फॉर्मूला यूज करना है, आपने सिर्फ उसको याद रखना है, बाकी कोई प्रॉब्लम नहीं होगी. आगे बढ़ते हैं. A solenoid of length 50 centimeter having 100 turn carry a current of 2.5 ampere. The magnetic field at one end. See, the formula is B is equals to mu naught Ni. Formula is B is equals to mu naught Ni. Now number of turn is small n is number of turns per unit length. Number of turns 100, unit length 50 centimeter, 50 by 100, 2, so that is 200 turns. 4 pi 10 raised to the power minus 7, 200 into 2.5. डेसिमल हटा दीजिए, 10 5 200. This is 20 pi 10 raised to the power minus 5. This is 2 pi 10 raised to the power minus 4. 2 pi 10 raised to the power minus 4. Pi stands for 3.14. When you put that value and when you multiplied it with 2, you will get 6.28. So option B is correct. Option number B is correct. Question number 5. A strong magnetic field is applied on a stationary electron. Then the electron, see the electron is stationary. The force that an electron experiences when it is in a magnetic field is Q into V cross B. Q into V cross B. And since the electron is stationary, it's electron, not election. Sorry, that was just typing error. Electron, since it is stationary, so it will not experience any force. F is equals to 0. So it will always remain stationary. हमेशा stationary होगा. Next one, the magnetic force on a proton, sorry, the magnetic force F on a current carrying conductor of length L in an external magnetic field is given by. एक करंट कैरिंग कंडक्टर के ऊपर कितनी फोर्स लगती है? I L cross B. This is the force experienced by the conductor. This is the force experienced by the charge particle. Q V cross B. That is the force experienced by the charge particle. That is the force experienced by the conductor. So this is C. Next is, if a charge particle is moving in a cyclotron, then it accelerate all the time. Cyclotron is basically a device which used to accelerate the positively charged particles through certain D. There are two D's like this. Particle will enter like this and it will, by creating more circular loop, it will this, and then it has been utilized as per the requirement. So this is D. A uniform circular coil, a circular coil 25 turns and radius 12 centimeter is placed in uniform magnetic field of this much, normal to the plane of the coil. If the current in the coil is 6 ampere, then total torque. See, torque is what? Torque is M cross B. M is magnetic moment. NIA cross B. A is area, B is magnetic field. तो फर्स्ट ऑफ ऑल सी, सर्कुलर कॉइल है, 25 टर्न है, 12 सेंटीमीटर रेडियस है, यूनिफॉर्म मैग्नेटिक फील्ड में है, परपेंडिकुलर टू द प्लेन ऑफ कॉइल. परपेंडिकुलर टू द प्लेन ऑफ कॉइल, कॉइल के परपेंडिकुलर है. ठीक है जी, मैग्नेटिक फील्ड जो है वो कॉइल के परपेंडिकुलर है. अब आपको लगेगा ये क्रॉस बी साइन 90, थोड़ा सा क्वेश्चन को समझिएगा. If the current in the coil is 6, then the total torque निकालना है. एरिया वेक्टर किसी भी कॉइल के, ये कॉइल है, एरिया वेक्टर किसी भी कॉइल के परपेंडिकुलर है, मैग्नेटिक फील्ड भी परपेंडिकुलर है, तो दोनों के बीच जो एंगल है वो 0 डिग्री है. NIAB sin 0, this comes out to be 0, तो 0 आएगा. ये मत कैलकुलेट करने लगे. एन तुम्हें गिवन है 25, करंट 6 एम्पियर, एरिया रेडियस गिवन है, एरिया निकाल लो पाई आर स्क्वायर, और मैग्नेटिक फील्ड 0.5 t. डू नॉट गेट कंफ्यूज्ड, जस्ट यूज द कॉन्सेप्ट प्रॉपरली. yes, it takes a lot to be the best. Just ask yourself whether you deserve to be the best or not. If yes, you have to take care of each and every concept very meticulously. ठीक है जी, यूपीएससी का एग्जाम है, you cannot take it lightly. In a moving coil galvanometer, the deflection on the scale by a pointer attached to the spring is, see, there are two torque. Number one, the first one which I have discussed in the previous question, NIAB. Second is K phi. Deflection के directly proportional है. यहाँ से K की वैल्यू कितनी आ जाएगी? NIAB upon phi. Oh sorry, we have to find out the value of phi, not this. Interchange कर दो. Phi K. So this is C option. Let's move to question number 10. The final torque on a coil having magnetic moment this much is 5T uniformly. If coil rotate through an angle 60 degree under the influence of, final torque बताना है. आपको m भी गिवन है मैग्नेटिक मोमेंट, b भी गिवन है sin 60, कितना m कितना है 25, b कितना है 5, sin 60 √3/2, 125 √3/2, सिंप्लीफाई करना पड़ेगा। चलो जी करते हैं। दिस इज 125 इंटू 1.73, मल्टीप्लाई कीजिए 173 से, 15 1 6 7 3 35 3 14 17 1 1 8 5 2 1 5 2 6 1 5 516.25 divided with 2, 258 something. This one is the answer. This one is the answer. Option number D. D is the correct one. Let's move to next one. In locate the south pole, the compass find the end of the compass needle that attract to an iron, point to the north, repel the south pole of a magnet, attract. See, already in the question it is given that the south pole, we have to locate the south pole, so that means it repel the another south pole, like sorry, like poles will repel, unlike poles will attract. जैसा कि चार्ज में होता था, like charge is repel, unlike charge attract, ऐसा ही पोल में होता है। Next is a bar magnet strongest magnetism near the pole. पोल के पास सबसे स्ट्रॉन्ग मैग्नेटिज्म होता है। These are factual question, facts हैं। When south pole of a magnet is placed, the unknown pole of another magnet, the two magnet repel each other because unknown pole is north pole. Wrong. एक south pole है, दूसरा north pole है, so they will get attract each other. So first one is wrong. Second, repel each other because unknown pole is south pole. Yes, that's correct. Attract each other because the unknown pole is south. See, option number 2 and 3 are contradictory. It means out of these two, only one is correct. So the second one is correct. So correct option is only 2. करेक्ट ऑप्शन इज ओनली 2। आगे बढ़ते हैं। एट द सेंटर ऑफ बार मैग्नेट द मैग्नेटिज्म इज मिनिमम, जीरो नहीं होगा, इट्स मिनिमम, इट्स मिनिमम। The magnetic field lines can be used to determine relative strength, direction, shape, and both direction relative strength. Yes, it's a good question. What is the question that हमें magnetic field lines का utilization बताना है। मैग्नेटिक फील्ड लाइंस का यूटिलाइजेशन बताना है। मैग्नेटिक फील्ड लाइंस किस लिए यूज होती हैं? जी हाँ, ठीक है जी। सॉरी, सबसे पहले डायरेक्शन, ऑफ कोर्स मैग्नेटिक फील्ड लाइन की हेल्प से हम बताते हैं ना, और दूसरा स्ट्रेंथ। नॉट सो डिफिकल्ट एंड इजी वन। सुपरकंडक्टर्स आर दोज I should say substance या body या element जिनको अगर हम कूल करते हैं, if we cool them down extremely, still they have a specific conductivity. Diamagnetic, mostly they are diamagnetic. है कहीं diamagnetic? Yes, it's the first one. Most exotic diamagnetic. Next, the strength of earth magnetic field vary from place to place. Yes, at some place it's very low, at some place it's very high. So it is basically vary from place to place. Point out the wrong statement about the magnetic property of a soft iron and a steel. जो एरिया है सॉफ्ट आयरन का वो बहुत कम होता है। अगर आप बेसिकली एक कर्व होता है लाइक दिस, दिस इज फॉर स्टील, दिस इज फॉर सॉफ्ट आयरन। HI कर्व होता है मैग्नेटिक फील्ड इंटेंसिटी और इंटेंसिटी ऑफ मैग्नेटाइजेशन का। तो ये हिस्ट्रेसिस बोलते हैं इसको बोलते हैं हिस्ट्रेसिस। 19, the magnetic field produced due to current carrying circular wire at its center is perpendicular. परपेंडिकुलर, ऐसे अगर वायर है क्लॉकवाइज है तो दिस तरफ, एंटी क्लॉकवाइज उस तरफ, ठीक है। फॉर मेकिंग अ स्ट्रॉन्ग इलेक्ट्रोमैग्नेट द मटेरियल कोर, अगर हमें एक स्ट्रॉन्ग इलेक्ट्रोमैग्नेट बनाना है तो जो कोर होती है, जो द इंटरनल बॉडी इंटरनल एलिमेंट दैट शुड बी ऑफ सॉफ्ट आयरन, वो होगा सॉफ्ट आयरन का। सॉफ्ट आयरन। सो दैट्स ऑल इन दिस, इट्स अ वेरी इंपॉर्टेंट टॉपिक, बहुत ज्यादा अनएक्सप्लोर्ड है, क्वेश्चन पूछे जा सकते हैं। एंड इफ यू genuinely wants to boost up your preparation, because we are not having so much time left for the NDA as well as CDS, so you should attend these classes as these should be very 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 beneficial for you. इतना ज्यादा कोई पार्ट नहीं पूछा जाता है साइंस का, फिजिक्स का, तो क्वेश्चन के थ्रू आपकी अच्छी प्रैक्टिस, अच्छी फिनिशअप हो सकता है। कल बात करेंगे इलेक्ट्रोमैग्नेटिक इंडक्शन एंड एसी का, ठीक है जी, एट द सेम टाइम एंड द सेम चैनल। तब तक पढ़ाई करते रहे। थैंक यू सो मच। जय हिंद।